Hi everyone, this is Deniz, and in this video I'm going to show you how to apply K-means with Rapidminer. This is going to be our first example of a clustering method. So clustering is different than classification because in this particular type of machine learning, which is unsupervised learning, we are not trying to find labels that are provided by us, but now we are trying to understand how the data is clustered, how it is distributed, and so that we can see the naturally occurring groups within the data. All right, so let's go ahead and check how we apply K-means clustering with Rapidminer. First of all, I'm going to require a data set. So I'll just go ahead and select one from the samples, which is the iris data set. So you're already familiar with this, therefore I'm not going to take a look at that. But for that I will require a K-means clustering block. There we have it. All right, so we provide this parameter K ourselves, and here by default it just says 5. Let's just keep it for the time being. There are ways to also optimize this parameter, but we will see them later. All right, so let's go ahead and just run this so that we see the clusters appearing here. So if we take a look at the model itself, we see that there are 5 clusters, and underneath those clusters we have a bunch of different items, right? So if we go ahead and visualize this by a scatter plot, yes, but then the value, sorry, the color should be the cluster. All right, so we have 5 clusters, and you see some of the data items are, well, within, so it's not properly clustered in my opinion. Of course, that depends on your particular business problem, but we also have several other data attributes here, so we can also go ahead and check that, because in this we can only see 2 dimensions and the projection on 2 dimensions of these clusters. So we already know that in this data set that we have 4 different classes, right? So maybe it's a good idea to just go ahead and set the K-means to 4, so K to 4, so that we are going to end up with 4 classes, right? Maybe it's going to be more natural for us. Let's see the visualization. Yeah, maybe slightly better. Maybe slightly better. All right, so let's go ahead and do some improvements in the design. First of all, so because K-means is using a distance-based approach for clustering, we require normalization. Otherwise, some of the attributes having, as a matter of fact, let's just see the statistics. Some of the attributes have different ranges of data, right? So different distributions as well. So if the range is larger than the rest of the data items, the data attributes, that particular attribute is going to be emphasized in cluster creation. So that can be an unfair bias. So what we need to do is to just normalize the data in order to just get rid of that. That's basically it. And yeah, let's go ahead and run this again. Yeah, so the outcome did not change that much as far as I can say. And the visualization is also going to be very similar, right? So let's also go ahead and check how we can measure the performance of the clustering. Cluster distance performance. I'm using a cluster distance performance operator. So clustering comes here, and the outcome, the example data set goes there. Here is my performance. I should connect it. Yeah. And here is my example set as well. So let's go ahead and run this. As a matter of fact, let's set the parameters. So we can just set several different things, although these are all going to be available in the outcome, in the output. But let's select the Davis-Bolden. So this is a cluster compactness measure, as a matter of fact. Let's go ahead and select that, and then we should also normalize the outcome. So let's see. All right, so we have again the clusters. Let's visualize it. We have 4 clusters again because we set K as 4. and check the performance. We have the Davis-Boden. The metric is minus 0.216, and we also have several other metrics. So see, these are the within centroid distance. For cluster 0, it's minus 0.25. For cluster 1, it's minus 0.12 here. So you can make the comparison between those clusters. All right, that is how you make sense of this number here. All right, so that was the K-means clustering. So next we will see how to optimize the number K, the parameter K here. Right.